Now, in the topic of polygons and geometrical constructions, let's take a look at checkpoint 11.3 part B. Now, this diagram shows three regular pentagons. Okay, so again, we are saying that three regular pentagons means all sides are equal. Okay, they're actually asking you for the side of one particular pentagon, and this will give you a 5 minus 2 times 180 degrees. Now, at this point in time, you should be able to acknowledge, the different terms and its number of sides. So you would have a 540 as a total sum of interior angles. Okay, so once done, to find out what m is, it will just be 540 divided by 5. You should have a 108 here. Okay, let's take a look at part 2. Now, if I have 108 over here and I have 108 over here, what is n? So n is just technically 360 minus away 2 times of 108. Now, what's the reason? The reason will be angles at a point. Now, remember, when you're using 360 degrees, it is important for you to state the reason to show where you get these 360 degrees from. So once you're done calculating, you would have your answer as 144 degrees. Okay, then let's take a look at part 3. Now for P, it's a little bit more unique. Okay, I'm going to use this as red color. So you see, regular pentagons means both sides are equal. All sides are equal, in fact. So what does this tell you? It tells you that this particular triangle is an isosceles triangle. So again, alright, if let's say I'm giving you these two angles, look at my shaded angles over here. Okay, they are 108 degrees each, which means the big angle, okay, of the isosceles triangle is 360 degree minus away 2 times of 108. Looks familiar, right? So it is technically 144 as well. Okay, then when you're looking at P, it will be 180 minus away 144 divided by 2, and that will be your angle for P. Okay, so why do I get that? Again, because of base angles of isosceles triangle. Now, whereas this one is angles at a point. Okay, so please remember your reasonings. Okay, that's exceptionally crucial. So therefore, P would be 18 degrees. Okay, so copy that down. All right, once you're done, let's move on. You can pause the video. Let's move on to the next part of the question. Now, additional pentagons are added to the three pentagons to form a closed ring, which is in shape of a regular polygon. Okay, find the number of additional pentagons needed to form the closed ring. Now, what they're trying to tell you here, okay, let me erase in this diagram. They're trying to tell you that I will form a closed ring here. So how many more pentagons do I need? Can you see? Okay, what does this tell you? It tells you one corner, okay, is actually n degrees. So what does this actually means? All right, it technically means that one side, okay, is actually n degrees, which is also 144 degrees. Which means, okay, let's say I will let the number of sides, okay, let number of sides of the closed ring, because if you realize they're all pentagons, means that they will all have the same side. Okay, so number of sides of the closed ring, all right, be n. Okay, so I'll have n minus 2 multiplied by 180 divided by this n to give me 144, because 144 is what we get. It is the angle of one side, right? Okay, so once you're done, you multiply. Remember, this is a multiplication, so it's 180n minus 360 equals to 144n. Okay, so once you have calculated, you should be getting a 36n equals to 360 degrees, where n equals to 360 divided by 36 to give you 10. Now, you have not ended. They told you that there is already 3 pentagons here. So they're asking for the additional number of pentagons needed. So therefore, additional number of pentagons needed would be 10 minus away 3 to give you a total of 7 as your final answer. Okay?